This video will be about rational functions. So when we say rational, we often represent rational numbers or functions as fractions. So a rational function is going to be when you have a polynomial divided by another polynomial. And remember, a polynomial is just any combination of x's and numbers. 2x squared plus 5x minus 7, something like that is considered a polynomial. A common mistake, though, is that you consider x over 7 a rational function. You can have a variable over a variable, or you can have a variable on the bottom. 7 over x is considered a rational function. But x over 7 is not considered a rational function because you could write this as 1 over 7 times x, which really means this is a linear function. It has just a constant times a variable instead of the variable being stuck in the denominator. And another requirement of rational functions is that the denominator cannot equal 0. So this bottom cannot be 0. Because when you are working with division of any type, you can't divide by 0 ever. That is not mathematically possible. You cannot do it. So as we work with rational functions, we want to be able to graph them. So let's start with the function time equals 50 divided by the rate you're traveling. So this is basically saying how fast you're going is going to affect how long it's going to take there. If you're going 50 miles per hour, 50 divided by 50 is 1, it would take 1 hour to get there. But if you're to travel only 1 mile per hour, 50 divided by 1 is 50, so it would take you 50 hours to get there. So we can draw a graph of this. The problem is, right now, we have no idea what a rational function looks like. So usually when you don't know what a function looks like, you start out by making a table of values. And actually, let me change this from x, rate, and time. Okay, so picking some values for our rate, and we'll say 1 mile an hour. Let's jump up like 10 miles an hour, 20 miles an hour, 30 miles an hour, 40 miles an hour. So if we plug these in, and I didn't pick 0 because again, 50 divided by 0, we can't do. So 50 divided by 1 is 50. 50 divided by 10 is 5. 50 divided by 20 is 2.5. 50 divided by 30 is 1.7. And 50 divided by 40 is 1.25. So now let's draw a graph. This will be our rate. This will be our time. And we can plot some points. A rate of 1 mile per hour is 50 hours. I should label these though first. I'm going to go by tens. So if you go 1 mile per hour, it took 50 hours. So 1 is just past the x or the y-axis, and then we're at 50. Then if we go 10 miles per hour, it takes 5 hours. So that's a big jump down. If we go 20 miles per hour, it's 2.5 hours. 30 miles, 1.7. 40 miles, 1.25. And we could keep going. So this ends up making this curved shape. And it never is going to cross the y-axis, and it's never going to cross the x-axis. It'll just keep getting closer and closer because it's always going to take some amount of time to get there, and you've always got to be going some speed to get anywhere at all, so we're never actually going to hit these zeros. So these lines we never cross are called asymptotes. Right now it happens to be that the asymptotes are actually on the x and y axis, but that doesn't have to be the case. They can be moved around. So asymptotes are these lines we can never cross. And we had only considered this first quadrant because when we were working with this problem, it was talking about times and rates, and you can't have negative time. But a full rational function is going to include more than just that first quadrant. We're going to graph the entire rational function, including any negative values. The basic rational function, which we usually call this the parent function, looks like this. So y equals 1 over x is the most basic rational function you can get. And I didn't do the best drawing, but it's kind of this curved shape in the first quadrant and this curved shape in the third quadrant. But the asymptotes still stay the same. Neither of them cross that asymptote, the horizontal asymptote or the vertical asymptote. So we want to be able to graph more than just this. So what we can do is we can expand this to say y equals a over x minus b plus c. And each of these numbers would do something to the graph itself. It's going to move it around, move it to the right or to the left or up or down, or stretch and shrink it. So this advanced format for it makes it so the graphing is a little bit different. Let's say we have y equals x minus 3 over x minus 1 plus 2. Each of these numbers will tell us something about the graph. So first we want to find what's called the vertical asymptote, that line we never cross that's going up and down. So the way we find the vertical asymptote is to set the denominator equal to 0. Since we can never have a 0 in the denominator, we want to know where would it have been 0, and that's where our vertical asymptote is. So if we solve this equation, we know x minus 1 equal to 0, we'd have to add 1 to both sides. X equals 1 would be our vertical asymptote. Our horizontal asymptote is given by c. So that number outside of the fraction at the end. So horizontal asymptote will be given by this plus 2. And when you have a horizontal line, it always starts with y equals. So y equals 2 is the horizontal asymptote. So on our graph, we now know that we have the vertical asymptote at x equals 1 and the horizontal asymptote at y equals 2. So we know approximately our graphs would look like this. But usually to get a more accurate picture, we now need to pick some values and make a table again. I'm going to put my table sideways just so I don't have to move off of the screen so that we still have everything up as we're graphing. So my x values, I'm going to pick stuff around my asymptote. So my asymptote is 1. I'm going to pick things nearby. So like 2, 3, 4. And then also to the left of it, 0, -1, -2. So now we plug these into the function itself to find y. If I were to put 2 in for x, I get 3 divided by 2 minus 1. You have to do the subtraction first. So that would become 3 over 1. Then the division, 3 over 1 is 3, plus 2 is 5. So 2, 5. 2, and then 1, 2, 3. I'm going to kind of end up here near where some of our other writing is. Then we replace the next one, 3. 3 minus 1 is 2, so this time it's 3 over 2, which is 1.5. Then we still have to add 2 at the end, so the final answer comes out as 3.5. So 3, comma, 3.5 is about here. And then we do it again with the 4, plug in 4. 4 minus 1 is 3. 3 divided by 3 is just 1. And 1 plus 2 is 3. So now we end up at 4, comma, 3. So now we know a little bit better how our curve will look. We just know that it will never cross the red or the purple lines. So then to get this other part of the curve, we plug in 0, -1, -2. So plugging in 0, 0 minus 1 is -1. 3 divided by -1 is -3. So 0, comma, -3. 0 means don't go left or right, and then down 3. I'm going to go ahead and erase some of this. We're getting kind of crowded. I'll redraw that graph in. If we were to plug in -1, 3 over -1 minus 1 is 3 over -2. 3 over -2 is -1.5, plus 2 is 0.5. So -1 and positive 0.5, which would be here. Then we plug in -2, 3 over -2 minus 1, -2 minus 1 is -3. 3 divided by -3 is just -1, plus 2 is 1. So -2, 1. And again, now we have a better idea of what our curve will look like. So our steps again were to find the vertical asymptote by setting the denominator equal to 0. Finding the horizontal asymptote, that's the number outside, or c. If there was nothing out here, if it was just 3 over x minus 1 and no plus 2 at the end, then your horizontal asymptote would be y equals 0. And then you plot points around the vertical asymptote. So you have to pick x values around the vertical asymptote and plug them in to figure out how will our curve look. If you do ever want to check your work, you can use a website called Desmos. So Desmos is just an online graphing calculator. You can type stuff in over here and it will plot it for you. And that'll help you check your work and make sure you're graphing things correctly. So that's the first half of this section. I'm going to split this into 2 videos because the second half talks about how to graph all the functions you should have learned up until this point. So it's going to take a little more in-depth on a bunch of different functions.